In this lesson, we are looking at pulleys for connected particles. So here we have a pulley with A and B, two strings, and we can see tension in both these strings. So the particles are interacting through the tension in the string. It's used to connect the two particles. So we have kg and 0.1 kg, and m is greater than 0.1, which will be very, very necessary now, this part. So when you see little aspects like that, make sure you highlight or circle them or underline them. I've just put in the acceleration, so we can see already that one is going up and one is going down because one of them is heavier than the other. So let's put in our first formula. So T for tension minus 0.1 G, G for gravity, is equal to 0.1 for mass, A. Okay, our second equation. So we've T and then minus T. mg minus T is equal to ma. So we've got a first start there for finding m. Now, I can cancel my t's, so T minus T, in terms of a simultaneous equation. You always try and build this up in some way. With Unit 5, with these kinds of questions, you do the individual components and then do a whole system. So it would be the same for elevator kind of questions, but more likely with strings or pulleys and with your rod questions on connected particles. So here I've cancelled out my tensions and I've now created another equation where I put these together. Okay. So essentially we've put two equations of motion together using F equals ma. I also have a tension of 1.5 newtons. So I have a value for T, and I think I could plug that in now to one of these. So which one has less than 3 unknown values perhaps? So 1.5 for T is equal to ma. That's our force. So we'll put in my first equation, T minus 0.1. Of course, you could have switched 0.1 G to 1 by now. But I just leave it there for visual purposes. 1.5 minus 0.1 G is equal to 0.1 times A. And from there we can find a nice whole number of 5 meters per second. Okay. From there, we can find m. We can plug that back in. So substitution. Always think of substitution. It comes up very, very often with these kinds of questions. So just write that in. So solving these simultaneously to find unknown values is really, really common. One of your main techniques. So mg minus 1.5 for T in our second equation is equal to ma, and A in this case is 5. So what we'll do next now is we will bring our m's together. So a little algebraic manipulation now. mg minus 5m is equal to 1.5, and your g, of course, is 10. So you have 10 minus 5. So we end up with 1.5. Divide g minus 5 on both sides, you'll get 1.5 over 5. .3. That's our first value, that's our first answer. That's finding m. Second part, find speed of A as it reaches the ground. Okay, so probably SUVAT. Let's have a look at this. We have acceleration as well. So we'll do that in the lower right hand corner here. Okay. That was part A, part B. So we're looking for velocity here. There's our formula. So U, have a look over the question, check your details. So U is 0. 2 times 5. We were given an S, we were given a height, I think. 0.9. Halfway through the paragraph in the description. V squared is equal to 9, V is equal to 3 meters per second.